1 minute over, so I think we can get started. Hello, friends. Thank you for coming. So this is my talk. Vulnerability response of last resort, dealing with under-maintained packages in the open source ecosystem. So brief intro, who am I? My name isn't there. A small oversight in doing this slide, but I'm Diogo. I'm from Portugal. I'm an engineering manager at Canonical, and my day-to-day work is, in essence, coordinating 12 years of security support for all Ubuntu LTS releases from 2014 onwards. So how I describe it is generally, I'm boiling the never-ending, ever-growing CVE ocean, one spoonful at a time. When I'm not working, in the very small time that I'm not working, I'm a OWASP chapter leader, B-Sides Lisbon regular, decent enough cook, board gamer extraordinaire, as some of you know from last night, and a master of trivia and cultural references. So let's kick us off. First, before, ground rules. This is a TLP clear presentation, so details were withheld where necessary. This is not about pointing fingers, it's just about sharing a story. Discussions follow the Chatham House rule after this. All opinions are exclusively my own. That's just how opinions work. And I'm not here to pitch you a product or sell you on an idea. It's just me talking about my experience in the past year dealing with these circumstances and what hopefully will be a seed for something that will come, perhaps VulnCon 2026. I generally said that my slides were ugly, but made with love. Now they're a bit less ugly, only a bit, because I use some AI magic and even more love, just to make it a bit more palatable. And of course, as obvious, anecdotes are not data. You have surprisingly little data about the things that I'm going to talk about, but they reflect my perspective and from the position where I sit in the ecosystem of the things that I observed. Everything else, the data should be accurate, except when I'm using hyperbole for the purpose of flair. That should be very obvious. So let's get started. First off, where do we sit in the ecosystem? The open source ecosystem is ever growing. In the seconds that I've started since the beginning of this sentence, more and more packages have appeared, more and more packages have begun to be used. And all the studies, even this study from the OpenSSF, shows that, like, an overwhelming, almost complete percentage of software that is being used right now, even the same software that is on this device that is showing my slides, uses some part of open source components. It is Windows, but it still has some open source in it. Open source is pretty much everywhere. As we look towards the ecosystems, you can see that continues to be an exponential or over-exponential growth. Like the number of packages that are being added every day make determining how many packages we have a veritable moving target. In the instant that you calculate how many packages exist in NPM or in Maven Central or any other of the other spaces, that number is already outdated. In those milliseconds, a bunch of other packages have been added. So package growth keeps growing as well. This is, for example, the number of source packages that we have included in Ubuntu in this case. So starting with Trusty, which is the oldest one that we still maintain, we had 22,000 source packages, and we are, in the most recent LTS release, up to 37,000. So in the course of these 10 years, we have grown by 15,000 source packages, which is a far significant rate. This is, of course, only represents a small selection of the number of packages existing in the ecosystem, but pulling them, bundling them, and distributing them is a significant effort that has been undertaken and continues to grow. So I believe Plucky, which is 2504, which is our next release, is already at 39,000 source packages and counting. And so, again, all of these numbers, you're going to see a pattern. All of the numbers in this presentation always go in the upward direction, except for one, which is a very important one. So again, population, world population, again, number keeps going up. GitHub users as well keeps going up and up and up. So this is from a GitHub blog recently where they marked that they had reached 100 million users. And they had reached 100 million users, I believe, 2 years earlier than what they expected. This again shows that there are more people pouring into the open source ecosystem. Like you create your GitHub account, you create your package, all of this refeeds into the numbers that we have seen where the ecosystem keeps growing and growing. Still, I did say that there was one number that wasn't possibly as growing as fast as we wanted, right? And that number is maintainers. Maintainers of packages are like Docker, and you always need more Docker. You always need more maintainers for packages. Like packages end up being created, but then abandoned at a pretty much almost the same rate. A long-term maintainer, somebody that is maintaining an open source package for an extended period of year, is something that is rarer. Creators, plenty. Maintainers for long-term, it's quite a different scenario. But the lack of maintainers is not a new issue. Like since the dawn of open source, it has always been a case where there's a number of individuals, for example, that maintain a very large number of packages and allow them to continue existing and to continue being updated. We don't have, like, for example, the possibility of having one maintainer per package. You do need to have concentrations where one maintainer or a small group of maintainers have to maintain a lot of them. The lack of maintainers is not a new issue. There's economic pressure, lack of incentive, support structure, and sometimes just regular life. I believe that the talk that took place in this room just before this was trying to ameliorate some of those conditions. So the Alpha Omega Fund trying to support economically maintainers and incentivize them to continue on their work. And another factor that we see is that package growth in itself leads to package decay. So it's a case where we keep pouring on more things into the ecosystem. You all know the well-known XKCD Comic-Con standards, like there are 14 standards. We're going to add one more. There are 15 packages that can parse a very peculiar format of JSON, and we should add one more. But this package growth, which we see, also leads to package decay. What happens to the oldest one of those JSON packages when the 16th one comes around? Is there anybody still with the interest or the animus to keep maintaining it over time? So what ends up happening is that packages fall out of favor, they are forked, they are wholly replaced, they are abandoned, or simply implemented anew. How many times have you looked at a repo and you see, oh, this seems very familiar, and it's basically a re-implementation in a new language of something that you have already seen and already existed. Maintaining things in open source packages requires a very particular mix of dedication, knowledge, availability, and selflessness, which put us in the perilous positions where, for example, we have packages that are very well known, like rsync is a salient example. It had a very visible RCE this January, I believe. You can read our blog about it. And it's used widely, and it has a single maintainer, which is Andrew, right? As you can imagine, this is not an ideal situation. This would be what we would describe as an under-maintained package. There's a single person there holding up the fort and making sure that fixes and all the things go where they need to be, okay? So now that we talked a bit about packages, let's draw a bit of parallels, like same thing. There are only two kinds of languages, the ones that people complain about and the ones nobody uses. And while I was doing this presentation, I was drawing parallels. There are only two kinds of packages, the ones that people complain about, and there's a new alert for XZUtils. Those of you familiar with open source security know what this is. It turned out to be rather benign CVE, but when these things start buzzing, it's something to pay attention to. But what are indeed the problems that show up in the packages that are used? You know this, that's why we're at VonCon, right? CVEs, like fleas on a dog. The number of CVEs keeps growing year over year. This data is from cve.org in the metrics page. I've seen some different numbers being thrown around. VonCon, please do not harm me. It's just ways in which we measure things, but it's very clear if you look at that. There's a huge jump from 2023 to 2024 where things simply grow. And these things seem to be comparable, right? We're growing in number of packages, we're growing in number of CVEs, but are they really parallel lines going in the same direction? Let's not make any mistakes here. Having more CVE IDs assigned is a good thing, despite the fact that there are still some issues to iron out. For those of you that don't know what DVWA, that's Damn Vulnerable Web App, and that's a CVE that somebody got assigned to it. It's a training application that is, well, vulnerable. The clue is in the name. You should not be able to get a CV assigned to it. I believe that this one was withdrawn, but everybody laughed heartily when they saw, What do you mean? The DVWA as a CV? What? That thing is a sieve on purpose. So assignments as a whole are growing fast, and there's obvious that certain CNAs lead the pack. So we have PatchStack, kernel.org, and WordFence are the top three CNAs that are just pumping things out. But let's look a bit closer. So package growth does seem to line up with CV growth. So we get more packages, we get more CV for those packages, and everything should be okay, right? We're keeping pace. But are we? What about the ocean that sits behind that wave? What about all the things that are left behind? What about the first package that implemented that JSON format rather than the 16th package that implemented that JSON format? Are we keeping pace with that? Let's talk about abandonment issues and under-maintained and unmaintained packages. I picked this graph for one very particular reason. Please, show of hands, who has used SourceForge in the past year? I guess that makes part of my point. This graph here was about a study about clusters of what constitutes active, inactive, and dormant projects in SourceForge using different thresholds. And this was from 2012, so about 13 years ago. And already at the point, it was quite obvious that we had a lot of projects that were already laying dormant. This is a tendency that does not, as far as I understand it, improve. SourceForge as a whole is now dormant, if you imagine. Can you think about how many packages you've used in 2012, 2010, that are probably still in use in some very old production system that you created, where the SourceForge repo is completely, well, just exists there. There's no interaction in the past 13 years. Dormant packages suffer from consistent abandonment over time, and that's not a new phenomenon. As I said, GitHub hit 100 million users, but a lot of those users do one commit, or they are following a trend that says, oh, contribute to open source so that you can get a job. They do one or two things, and then they walk away. And whatever code exists there has a commit pushed and just nothing else. Okay? So let's now role play a bit then through one of the scenarios. I use GitHub here because it's the de facto thing where most packages are living. And let's imagine what happens when a submission, a report, a message comes in to one of these repos where a package exists. And let's imagine it in the various scenarios that we are facing. So we're looking, for example, to compare between a well-maintained package, an under-maintained package, and spoiler alert, no, sorry, I said an under-maintained package, and spoiler alert, an unmaintained package. In the case of an unmaintained package, this goes nowhere. You send a message, it hits straight to the void, that thing at the top of the box. But we'll visit the void in a bit. As you stare into the void also stares back. So a message drops in, you have found this thing in your package when I was doing some testing. I don't know what to make of it. And this is important. Sometimes people that are sending in an issue, they don't know what it is. There are a lot of security research is running a piece of code and going, oh, that's odd, and then checking if somebody has reported on it before. So let's say we get this message here, and let's try to look at the possible outcomes of what this thing that is reported is. So true positive and true negative, in a sense, this is a vulnerability, this is not a vulnerability, are fairly straightforward. Even for under-maintained packages, things generally run its course in a reasonable amount of time because the outcomes are pretty clear. If you come up with something and you say, oh, if I run this and I pass this payload, this deletes your whole system. Yeah, that's pretty straightforward, that you're not removing the French language pack, and it's indeed an issue for the system. The process runs fully. The key differences here are in how complete the process is in a well-maintained package versus an under-maintained package. For example, in an under-maintained package, the person that is handling it might not know how to do a CVE, how to get a CVE assigned. GitHub now really helps with that. I believe that a blog came out just the other day explaining how they make the tools available for people to do it or use the GitHub advisories. The usage of private reporting is also something common. So again, GitHub feature that you can use to send in a report in a discrete manner rather than open a public issue like the one that we saw that basically says, hey, I found the thing. The fact that the issues are public are something that is going to play an important role here. And the patching methodology, which is ideally, we should not be patching things in the open. We should then just release it when we are ready to release the vulnerability outside. For the negative case, so in the case where it's not a vulnerability, it's just something that was reported, the time to verdict is generally the key metric. Like in a well-maintained project with a lot of people looking at it that are well-trained and know the triage procedure, making the determination that this is not a security issue, it's a feature, or it's a bug, but it's not a security bug, is rather fast. In an under-maintained package, you might need to be chasing the maintainer for 2 weeks, sending out a few emails. Unsurprisingly, more resources tend to lead to quicker and better outcomes. False positives, again, come in various shapes and sizes. They can be issues, just not security issues. For example, they might not fit in what the maintainer considers to be a security issue, or something that is simply nothing at all. Hello to the curl hallucinations. Those were very fun to read. And in the case where a CV, for example, is assigned that ends up being a false positive, in an understaffed project, there might not be the willingness or the motivation to go and contest it. And you could simply just let it roll. The issue with keeping a false positive around is, this is a salient example that I dealt a lot in my previous role, which is this CV for OpenSSH, where basically the maintainers do not believe it to be a security issue, but it keeps popping up in vulnerability scanners. Keeping false positives around creates compliance problems down the line for whatever package they might be. And then this is probably the worst case, which is the false negative. In a well-maintained project, this is hard to read, but on top is basically there's a false negative. You say, this is not a security issue, but it's a well-maintained project. It's a popular one. So people come around and say, this doesn't sound right. Please revisit. There's clearly something here. And it generally circles back to the queue, false standard operating procedures for vulnerabilities. If you get a false negative in an under-maintained project, well, the same sentences may show up, but there's a possibility that it just disappears into the void and nobody revisits the ticket again. And you end up with a situation where there's a public issue on GitHub that fully describes an attack that didn't get a CV assigned, that got considered as security, and all the information is there for whatever person with whatever intentions might decide to use. Right? This is the worst outcome. What is it? Let's look back at the box. Remember the void. What's in the box? What ends up being inside that 4-square box where we fit it to the top slot? Well, dragons. This is a message from OWASP Security just a few days ago, where basically there's a library, libspf2, that appears to be the standard way of parsing SPF records in C, email thingies. I wonder who has need of that. But development is mostly stalled. The package has, for all intents and purposes, been abandoned. In the project's GitHub repo, there's an unmerged pull request claiming to fix a use after free bug. So this puts us in a position where use after free is something that ill-intentioned attacker could pick this up and go do something with it. But we are in a point where what's going to happen to here? I didn't have the foresight to link to the pull request, but it's something that was submitted in 2016. So it's already almost 10 years old, and somebody just now noticed it. I wonder how long it has been there, at least 2016 or previous discovery, and what might have been done with it. Okay, here's an even fresher example that I picked up when I was doing this, preparing for this. I was already at VulnCon. Like this is a thing in the function to its giflib. And it, in essence, was, oh, this is an issue that is being reported now. It's a 2025 assigned CVE that was apparently reported in 2016. And apparently it said, oh, yeah, this thing is all fixed. But it wasn't. Okay? There's a lot of things lurking. And of course, for bonus points, this is SourceForge for those that have never seen that wonderful interface. These things exist and are out there, right? And then we get the usual, oh, I'm sure it's fine. These packages aren't an anything issue, which is in part true, but that's the beauty of compiling from source. They don't have to be. You can go there, you can pull the source, you can compile it yourself, and you can use it. That's the beauty of open source. Oh, but nobody is using these packages. Well, I digress. I disagree. libspf2 is the first result when you search C library to process SPF records. I don't know why somebody's running a web server on C, but power to them. People know better than to use abandoned packages. But sometimes no alternatives exist. Like, for example, I cannot name any other C package that does the same thing. So we should assign a CV for it then. Well, we don't even know if this is really an issue. The PR is from 10 years ago. The maintainer is gone. What do we do here? Okay, we should assign a CV anyway. Okay, but what is the path forward to ensure that we assign a CV, this starts showing up on scanners, but then what? How do we address this? Like, we have no path forward here, okay? So this is to show that you can hop now on GitHub and your search queries away from finding orphan issues and orphan projects that just might be security related. Now with these newfangled LLMs, maybe you can whip up a crawler that reads through those PRs and flags what might be juicy things. Who knows what 0 days or 10-year days, wait, does that count? May be buried in those very old messages. So, and beyond repos, you have emails to domains that lapse, messages to forums and IRC channels that have gone unanswered. Just a lot of things lost into the dev null analogs, right? In essence, when we are looking at abandoned packages and vulnerabilities in them, it's what happens to the whole when the cheese is gone. I'll let you understand what the cheese is, obviously the package here, right? So what happens to these vulnerabilities? Are they vulnerabilities? Yes, I believe so, but what can we do about them, right? Indeed, it's what it says. Like, how many things might be out there in the ecosystem and abandoned packages that need redressing? So, all right, let's go what we can do about this. But before, a small detour. For those of you not in the know, this is a Hungarian mathematician called Paul Erdős, of the Erdős number. You perhaps have heard of it. And Erdős has a thing that I really love. It's a mathematical result I love, which is called the friendship theorem. I'm not going to read this. This is the Wikipedia definition. I asked AI to help me this. Like, this is a very dull thing. Could you help me make the theorem a bit nicer? And this is what it shows up. No, my slides are not so ugly. But in essence, the friendship theorem states that if every pair of people in the room, like for example, us, have exactly one friend in common, then there is someone who is friends with everyone, right? And why do I want to point to the friendship theorem to draw a parallel here? In essence, this is one of the things that I want to talk about my talk, which is, all right, we don't have exactly one friend in common between each of us, but we do have like something that we all know and know to be common between us that we can point to, which is in essence, open source distros, for example, like the one that I work at, right? So the proposal here for the vulnerability responder of last resort is that armed with this aggregate knowledge of the ecosystem, distros, which are well known by everyone that is pretty much participating in the system, like the devices that they are running when they are finding these vulnerabilities and reporting and are running a distro of some sort, can be well positioned to connect reporters to maintainers, help reporters structure their communication to ensure that they are actionable, help maintainers as well with triaging issues and patches, and assisting with disclosure coordination process. This applies, for example, for the under-maintained side of things. It's what I said at the start. Like, for example, if you're a maintainer that has no clue of how to assign a CVE, and you would like somebody to handhold you through the process, and if it's a package that is somewhat carried by a distro, hey, perhaps a distro can like lend a hand. It's in its own, there's obviously an element of self-interest here. I'm not going to say that this is fully selfless, but there has to be something here that distros put themselves in a position to get access to potential issues to stay at the forefront of security, which I believe ends up benefiting all. So the idea here, the model's proposal, so this is like the inception, the seed for the thing that I hope to keep developing over the course of this year and more, is to be like a beacon, like a candle in the dark. So first, it's to get a bit of our data on how much might be lurking below the surface. So for example, these PRs to well-abandoned repos on packages that are distributed and in use, how many of those are out there? I didn't really look too hard, but I don't think we have really strong numbers on what might be out there. That's the whole point of like these unknown vulnerabilities. We could also assist reporters in getting where they need to be. For example, if you are a reporter and you're trying to report something to a package that is dead and gone, hey, perhaps we know someone that owns one of the forks of it, and maybe the code is the same. Or maybe we know someone that implemented a different version of it, and we can redirect that report and we can check other things. It does not have to be, oh, I tried to report this thing, the package is gone, it goes straight to dev null, and we never think about it again. On the other side, for under-maintained packages, so packages with poor resources, we can also assist maintainers with coordinating disclosures. If this is in the interest of everybody involved, we can help out with this. Like in the case I said for rsync, there was a great deal of collaboration considering that it only has a single maintainer. For the findings that, I believe it was Qualys actually, kudos to Qualys if they're here, brought up. Another thing is, together with this thing for hard data, is to identify packages that have fallen off the grid. The difficulty in this is basically setting the criteria because, oh, we look at activity on issues or things or features that are proposed, but you can look, for example, at packages that are very crystallized, and those packages don't have any activity, but that's on purpose because there's nothing to do there. There are no new reports, there are no new features to implement. So there is no easy, simple metric by which you can determine that this package is gone. There's also the thing about the moment where you check, because, oh, if you're checking no activity in the past 3 years, and you check, and you only check 2 months from there or 3 months from there, maybe it has gone abandoned in the T+1 second. And what happens in that 3 months window, right? The other is, again, have alternatives ready when crystallized packages get shattered, like that SPF package there. It was pretty much the only option that exists for doing that thing for C. Do we have any options if that thing comes out with a vulnerability that simply cannot be fixed because it's part and parcel of the design, or it has a cryptographic flaw of some sort that is non-fixable, right? And most of all, to do all of the above earnestly and for the collective good of the open source ecosystem. So in sense, the beacons are lit. We will render aid. So thank you all for your time, and I'm open for questions.